Good morning, friends. In the pre-commissioning test, we will check the polarity of the power transformer, of the CT, of the PT, and the auxiliary transformer. So, we know that we are using 6 volt DC for CT's polarity checking. But why? Because DC is act as short circuit for inductor. That means it will be a short circuit. Because frequency is 0, so it will offer 0 resistance or 0 impedance for this DC, 0 resistance. So it will allow the DC. But we are testing transformer, means if primary is short circuit, there will be nothing will be in the secondary, but we have to check the polarity of the secondary of the CT. Without mutual induction, means without any changes of the current or voltage, the secondary will give nothing, 0. So if you use DC in the secondary, it will be inactive. So what will you do? Short circuit means it will allow maximum current in the primary, but as there is no frequency, nothing is in the secondary. No action on the secondary. But we are aware that some changes also there in the DC. When you close the switch, the current will rise from 0 to the load current. And when you switch off the switch, it will become load current to 0, come down to 0. So these changes will be sensed by the secondary. This is the changes, and any changes of the flux linkages, the secondary will be active. So we are using this principle. What we are doing, we are checking the polarity with the 6 volt DC, and we close the switch and immediately release the switch. But when we close the switch, the current is rising from 0 to the load. That time it will give a flick. But when you release, then again it will give flick, but it is in the opposite direction, because initially it is 0 to load current, and when you release it is load current to 0. So the deflection is opposite. But we will take the first deflection. When you close the switch, check if it is positive flick or negative flick of a zero-centered ammeter. The positive flick will ensure that the positive terminal of the ammeter is S1, and the negative flick will ensure that the positive terminal of the ammeter is S2. So positive flick will give S1 of the positive terminal of ammeter, and negative flick will give the S2 of the ammeter positive. So this is the system we are using. For this reason, we are using this DC and taking that facility, the changing period of DC, 0 to load current and load current to 0. I think now it is clear to you. As the voltage is very little, current will be also minimum, but during short circuit also it will not harm the current transformer. Okay, thank you, friend.
The P1 terminal of the current transformer primary is connected to the positive side of the battery through a push button switch, and the negative terminal to the P2. and the secondary, the both the terminal is connected between positive and negative with a zero centered ammeter. Now if the push button switch closed and released and the deflection found initially to the clockwise direction, then the positive terminal will be S1 and negative terminal will be S2. Otherwise, if the deflection in the reverse side, that is anti-clockwise side, then the positive terminal will be S2 and negative terminal will be S1.
Friends, this is the system of part transformer phase identification. It is called AC test. Here we will give 400 volt AC and the output of the 25 kV side will be 75.76 volt and connect just like my figure. Phase and neutral is connected in HV side of the supply of 400 volt. Then red phase is connected to the voltmeter and other end of the voltmeter is connected to the LV side one bushing. Identical to check the identical phase, and the other bushing of the LV side and the HV side will be make short, and the HV side other bushing will be connected to the neutral. This is the system. Now if the voltage is showing 325.24 volt, that means subtractive 400 minus 75.76, then it is same phase. That means both HV side and LV side across the voltmeter is phase. But if it is not the subtractive, it is additive, then the voltmeter HV side is phase and voltmeter LV side is neutral. This is the system. Take care and check it. Okay, thanks today. So friends, I think now it is clear. Across the voltmeter, the voltage is the main connection. You have seen, no problem. But after that voltage, subtractive means same phase, and additive means the next phase. Next phase means it is connected in the other side of the bushing of the LV side. If why it is happening, there is a question, because when you have given 400 volt in the incoming side, the outgoing side is 75.26. Now if it is voltmeter is showing one side is 400 volt and another terminal is connected with 75.76 volt, if the phase sequence is same, so voltmeter will show the subtractive, because one end is 400 volt and another end is voltmeter will show the voltage difference. The 25 kV side is one terminal is phase terminal is 75.26 and voltmeter other end is 400 volt, so it will show the subtractive value, because voltmeter is giving the potential difference, voltage difference. Now if you connect it wrong, then what will happen? Your one end is 400 volt and another end how much? Another end you have connected after the 76.76 volt coming to 0. That terminal is 0. The opposite terminal, that means neutral is 0, but you have connected with the other terminal. So the phase is coming, then entering the 25 crochet, one bushing and going, dropping through the secondary coil, then it is becoming 0. So it will show additive. Better to show it in diagram, but okay, you simply remember it, that subtractive voltage will show that phase sequence is same across the voltmeter, and across the voltmeter if it is additive, the phase sequence is opposite. This is the rule. Okay friends, thank you. Okay friends, today after this, in the next day, we will discuss the other thing. Okay, all the precautionary test we will discuss. Thank you.